welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I am your host. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe. And today I'm joined by comedian Tiffanee Lee. Thank you so much for being here with me today. Tiffanee, can you tell the listeners where we're recording?
Oh, yes. We are recording in an amazing, warm, and cozy pumpkin patch.
Yes, it's stunning out. The leaves are in top shape, and the colors are stunning. We're going to do some leaf peeping after this, I think.
I love it.
Great. Yay. Okay, but before we get to the leaf peeping, we are going to be talking about one of the, I'd say, most influential astronomical bodies in our lives. Today we're talking about the sun, and Tiffanee, you chose this topic, so I'm curious what drew you to the sun, aside from its massive gravitational field.
Well, it's just associated with being happy. And so, when little kids draw pictures of the sun, it's always smiling, it's always on a beach, it's always giving life and warmth and joy and vacation vibes. And so I was like, you know what? Let's do the sun. I'm a comedian. It fits my personality.
Yes. And we're getting into the dark time of the year. So maybe by hearing about the sun, it will stave off some of that seasonal depression for us in the Northern Hemisphere.
Exactly. See, you're with me.
I'm with you. Is there anything you would like to know about the sun before the episode is over?
So I'm not a conspiracy theorist, but I might have conspiracy theorist vibes sometimes. And people are always like, the sun is going to burn out. Our planet is going to end. It's going to be like a doomsday. And I'm just like, yo, is that even possible? Like, what are we talking about here?
Okay. Yeah, we're definitely going to cover that for sure. Because that's one of the, I wanted to cover the sun's whole lifetime. So we'll definitely get to what's going to happen to the sun in the future.
Yes. Okay. Really,
Good.
calm my nerves.
That's the whole point of the podcast, is to give people knowledge so that space seems less scary and more familiar, which actually brings me, I think, to the prelim exam that we offer here at the Podiversity, the Pale Blue Podiversity. All of the newcomers to the Podiversity take this intro exam. There are no right or wrong answers. It's just to get to know you so that we can, figure out what classes would be most exciting for you at the Podiversity. And the first question on this exam is, what's your current relationship status with the universe? Because it sounds like maybe you have an interesting one.
Yeah, okay. I was nervous. You said tests, and I was like, oh my God. And then you started with, what's your relationship? And I was like, oh, Lord.
Right, I'm starting with the big hitting questions.
I know. I was like, ooh, Lord, okay. I do really believe that the universe speaks to me if I'm open to listening. I've had a couple of times in my life where I was just like very strong-willed. I'm a Capricorn. I'm a very strong-willed person.
Hello. Hi. A January or a December Capricorn?
January.
Same.
So we are very much like about our business. And I was like, it's going to tell me what to do. I'm going to do X, Y, and Z. And the universe was like, no, you're not. And I was like, yes, I am. And we all know who won that battle. So it's taken me a little while and some growth to understand that sometimes the world is talking to you and you need to really pay attention and listen. And it's for your own benefit. So I feel like I'm on the journey to being one with the universe to, really realize my own potential.
Okay, that took a philosophical turn. I'm sure that you have such a deep potential. Well, I recently started using the word pronoid or pronoia. Have you heard of this?
No, I haven't. Do tell.
It's the opposite of paranoia. So instead of thinking that everyone is out to get you, you think that things are just going to work out for you. And I've developed the sense of pronoia with the universe, where I truly do believe that I'm one of its favorites and that it's looking out for me.
I love this. Oh, I'm going to, that's now part of my vocabulary. Thank you.
You're welcome. Okay, the next question on the quiz, again, no right answers. Do you have a favorite equation?
Okay, so I suck at math. It was always one of those things that I had an intense struggle with. But the equation that I use constantly is 2 times 5 equals 10.
Interesting. Are you dealing with a lot of pieces of lumber or something?
Yeah, no, you would think. But what happens is I'm often having to figure out percentages just in daily life. And I can never remember how to get the percentage. I have used that equation more times in my life than I have used anything that I have learned in a math class ever. So that's going to be it.
Yes. You're in New York. I imagine you do a lot of brunches, a lot of, meals out with friends, and calculating the tip at the end works with that. The way I do it is I just move over the decimal by one place to the left, and then I multiply by 2. And that's how you get to 20%.
Yeah, everybody has their own little things to remember that. I also heard if you double the tax, it would be approximately what the tip is. And so, yeah.
Okay, see, little math tips.
Yeah.
You get small pieces of math advice from the pod. Okay, so you mentioned that you're a Capricorn, a fellow January Capricorn. I'm wondering if you feel like your zodiac sign fits you.
I do feel like it, but I also feel like there's a lot of wiggle room. So
just like a Capricorn to say.
Yeah. I'm like, I don't know. I don't know how I feel about this.
This system doesn't really work.
Right. Let me tell the system how I work. That is very Capricorn. But I did read somewhere that there's more than 12 signs, and that 12 was kind of watering it down, and there was like a 13th sign or a 14th sign, something like this. And so at the time when I looked it up, I was like, oh, that does sound a lot like me. So I feel like I definitely have a lot of the Capricorn energy. But the things that I feel like don't really fit me is I'm also an empath. So people are always like, the Capricorns, they'll just step over you, they'll climb over you, they're heartless, they're cold, they're whatever. And I'm like, no, actually, I'm very much like, are you okay? Did I hurt your feelings? Like, even as a comedian doing crowd work, you will never catch me insulting an audience member, because my immediate reaction would be like, did I hurt your feelings? Was that joke too far?
Wait, I want to come to one of your shows. It's my greatest nightmare to be heckled in an audience, and I feel like I always get picked on if I'm visible to the stage.
No, I would never pick on anyone ever. So yes, you could sit at the front row of my crowd, because if you started crying, I'm going to start crying with you.
Okay. All right. Good. I'll be front row center at your next show.
Yeah, you're safe.
The next question is, what do you think is the best planet?
Oh my gosh. I have never, ever thought about that one before. Well, I recently saw somewhere that there is a planet that's covered in diamonds.
Yeah, based on the pressure in the atmosphere of it, yeah.
Yeah, and I don't know anything about this planet, but I imagine that it's got to be beautiful. And my imagination is telling me that I would land there and it would just be like bling, 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 bling everywhere you look. It's got to be gorgeous. So that could be completely wrong. It could probably all be in coal. I don't know. But my imagination tells me that that would be the best planet.
I love that. You're the first person to name a planet not in the solar system.
I am so extra.
Yeah. Star-studded, diamond-crusted planet. You went with that over any of the ones we could actually get to. And I respect the hell out of that. Okay, so let's imagine you're going to this planet. Let's imagine you're an astronaut on a mission. What song are you listening to during blastoff?
Ooh, okay. Gosh. The first one that popped into my mind was I think it's Rihanna's Shine Bright Like a Diamond.
Yes. I think that'd be a good blast-off song. It gets you moving, so when you start shaking from the spacecraft rocking back and forth, it just feels like you're dancing more.
Yeah, exactly. And if for some reason I can't get that, then I might get that Diamonds Are a Girl's Best Friend. I think Marilyn Monroe sang that or something like that. It's an old song from an old movie, but everybody knows it. It's the one where she's in all that satin and pink and dancing with all those men on stage.
Yeah. I like that you have a backup option in case, NASA can't get the licenses or something.
This Capricorn is really coming through this afternoon.
It really is. I love that for both of us. You're doing good Capricorn representation today.
Yes, thank you.
I'm wondering where you'll go with this one. Would you rather be an M-type star burning low and slow, or an O-type star that burns hot and fast?
Oh, low and slow. That's an easy one. That's my whole life. I'm just like one step at a time. We'll win the
Hmm.
race. We'll get
Nice.
there. Yep.
I think I might be. I want to be an O star. I want to be an O star so bad, but I think I am an M star.
Yeah, yeah. You know what it is? It's the idea that if you're just going hot and fast, that you might miss something or forget something or something's not going to be done properly. So it's kind of like, no, we'll
Hmm.
just take our time and enjoy the moment and make sure we get all the things.
Hmm. Hmm. Yes. Pay
Yeah,
careful attention. Cross all the T's, dot all the I's.
exactly.
That's an M star thing. Our sun is neither of these types of stars. Our sun is right in the middle, so it's pretty average, and we'll get to that after the quiz. We have two more questions.
Okay.
The next one is, what's scarier than a black hole?
Ooh. Uh, I'm not sure what this is called, but I think of a black hole as infinite space. And so
Mm.
I think what would be scarier than that would be infinite time. So, yeah, I don't know if there's a term for that, but just like having this void of time that you don't know when it'll end or how to fill it or where it goes, I think that would be
Hmm.
terrifying.
I don't know if you'll find this to be good or bad news, but black holes are also kind of places of infinite time. There's this process called gravitational time dilation. And when you get closer to a really strong gravitational field, like a black hole, time actually starts to slow down. So when you get closer to the black hole, a second lasts like 1,000 years.
Oh, that's wild.
Yeah, so I guess black holes
Oh,
are the
no, 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 no,
scariest
no.
thing you can imagine.
Yeah, I'm like, wait, what is happening? Oh no.
Yeah. Yeah, you don't know it because you're in it, but from outside, from a different reference frame, people looking in can see that you're moving real slow.
It's just so crazy to me. That's weird.
Space is really weird. Yeah. Okay, so nothing is scarier than a black hole. Now for the final question. What constellation should we get rid of, and what should we replace it with?
I don't even know the constellations like that. I'm like, oh, wait, hold on. Okay, so I'm gonna just take a wild stab in the dark because
Okay.
I don't know any constellations other than like what Big Dipper, Little Dipper, like the normal
Those are
ones.
constellations, yeah. All of the zodiac signs, those are constellations.
Oh man, oh, well, if you tell me to get rid of a zodiac sign, that's me bringing my personal trauma into it. I don't think we should go there. Are there any constellations that do not help, like, tell you direction? Like they're just out in the sky
Ooh.
being useless.
That's a good question. I'd say for navigational purposes, constellations are really good at giving us north-south information, except for the zodiac signs, because they're close to the equator, so they don't tell us as much information about north versus south orientation.
Well, in that case, my brother's gonna hate me for this. My brother is a Leo, but I'm gonna be like, bye, Leos. Y'all are so dramatic.
So you're getting rid of the constellation. Are you replacing it with anything?
Maybe like a Capricorn Junior, someone I can train.
Just a little goat.
Just a baby
A
goat.
little goat
Yeah,
fish.
yeah. We're just gonna say bye to the Leos, and we're just gonna put a little baby goat there, and I'm gonna be like its mommy goat, and I'm just gonna have a little mini me in the constellations. Yes.
I like that. I like that. I don't think they're anywhere near each other, too. So it could be a story about how the baby goat wandered away from the mama goat.
Yeah, yeah. We'll make a great. It's gonna be amazing.
I love this. But you did a great job. This was a really revealing quiz. It told me enough about you to figure out what other classes you might be interested in. Clearly the sun class. Maybe a constellations class. But I think that we should put you in charge of our playlist making department because no one has thought of having a backup before for licensing problems. You just were really on top of that. Good for you.
Thank you. Thank you. And I'm happy to know that I passed the test. Good.
With
Okay.
flying golden colors. Golden for the sun, which we're talking about today. It is the linchpin of our entire solar system. It is one of the biggest factors that led to life existing here on Earth. And, it's how we time ourselves. It's how we schedule our days. So the sun is really important. I'm glad we're finally covering it on the show. Are you interested in hearing some myths and some stories that cultures have been telling about the sun before we get into the science?
Absolutely. I have a whole book on like mythology and stories. Like I
Ooh.
love hearing any kind of story, any kind of myth from any kind of culture because I believe we're all telling the same story in different ways. So I find them fascinating because I feel like they're all based in some sort of truth. So yes, if it's story time, let's do it. I'm in it. Let's go.
Myth story time. Yeah, so humans have been telling stories about the sun for tens of thousands of years, if not hundreds of thousands of years. And that's all based on observations that they made of the sun. It wasn't just coming from nothing. There were different characteristics of the sun that they noticed over time. Things like the regular day-night cycle, that they could literally set their non-existent watches to it. They knew that the sun would rise and set every single day. They also saw that the sun moves north and south over the course of a year, and that was tied to seasonal shifts. They saw that the sun moved through a specific set of constellations. Once we defined the constellations, the Babylonians did that like 5 to 6,000 years ago. And they saw that the sun moved through a set of, at the time, 12 different constellations in the sky. Now it's 13 or 14. You were right. And they defined that path in the sky. They called it the ecliptic. And they made those constellations special. And so that's why we have the zodiac signs to begin with. They also noticed that the sun was really important for crops, that it gave us warmth, but that on the flip side of that, it could get too hot. It could be too harsh and too bright, and it could actually damage crops, and it could hurt and harm people. So that it had this like dual nature of nurturing and harming, which was interesting, and it got wrapped up in a lot of stories around the world. Often the sun was either seen as a god or a part of a god. So in some parts of Egyptian mythology, the sun was Ra's eye, like the god Ra's eye. In other mythologies, the sun wasn't a god at all, but it was an object that was handled or maintained by a special figure. So to the Navajo, who are like indigenous people in the United States, they have a sun bearer who is not a god, but is still like a sacred deity of sorts. His name is Sohanoi, and he carries the sun in a little pouch across the sky every single day. And when he gets home, he like puts the bag up, he hangs it on his wall, and he has dinner with his wife and his kids. And the next day he picks it back up again. And I think that more guys should be taking lessons from Sohanoi. We need more Sohanois.
I agree. Yes, yes.
Mm-hmm. Often the sun deity is said to ride some sort of vehicle across the sky. So Ra would float in his solar barge. The Baltic sun goddess Saule rides across the sky in a chariot pulled by white horses who never get tired and they never sweat. Another thing from mythology that I really want.
Okay, okay. I love that they thought about the sweating of a horse. Okay.
They did. Well, they can't have their sun goddess just like as they're going through the sky being hit with droplets of sweat from her galloping horses. That's not very godlike.
That's not classy. It's not classy.
Mm-hmm, mm-hmm. Saule is nothing but classy. She goes to the end of the sky and she tends to her apple orchards and she takes care of like lost children. Saule's great.
Yeah, I feel like that somebody, when they invented her, was maybe in menopause or perimenopause. They were like, she's the sun god, but she does not get hot flashes. She does not sweat. Like, it was definitely a woman who put this together.
Mm-hmm. You're so right. But that same woman, I'm glad she didn't live long enough to see us learn the science of the sun, because you'll see that the sun is kind of going through hot flashes.
Oh, dang.
Like right now. But yeah, you're right. People back then, they wanted their sun to be this like divine figure, this all-powerful figure. And so different cultures have their own stories that reflect what the sun looked like to them. So to the Inca, they had their sun god Inti, who was really angry and required a lot of sacrifices. And they explained certain phenomena like a solar eclipse as Inti getting mad at them and turning away from them. And that's because they lived in the desert with a really harsh sun that could seem like it was really mad at them. And if you compare that to Amaterasu, who is the Japanese Shinto goddess of the sun, she's really nurturing and she takes good care of her people. They have this one story where Amaterasu leaves, she goes into a cave and she takes the sun away from the earth, and chaos ensues. The crops start dying, the animals start dying, people are really upset, and the other gods, do everything they can to get Amaterasu to come out of her cave. And then there's a big celebration when she does. So that shows you like the difference between how these cultures related to their sun because of their climate. Like Japan has a much more mild climate. They get more rain. They see more sides of the sun. And so I love that the astronomy of these things incorporates into the myths like this.
Yeah, I love that so many of these sun gods are women.
Yeah, a lot of people think of the sun as a very masculine figure, and then opposite that, they think of the moon as a feminine figure. But different cultures have swapped it. In Finnish folklore, the moon and the sun are both women, and they're like best friends who weave dreams together, but they're just friends.
I love that though. That's so cute. It's like, hey, bestie.
I know. In my head canon.
Yeah, it's like, girl, you got that moon thing. Girl, you got that sun thing. Hey, like I like that one.
Yeah, I'm a big fan. And then there are other cultures where it's not just one figure who makes up the sun, but people kind of take turns. So to the Nahua, or the Aztec, they have this myth called the cycle of 5 suns. And in this myth, 5 different gods sacrifice themselves to take turns being the sun, and things keep going wrong. So the first one to do it, he leaps into a bonfire. His name is Tezcatlipoca. He's the god of night. And I think it's ironic that the god of night is the first one to become the sun, but he does. He's then overthrown by his brother, Quetzalcoatl. And then Quetzalcoatl gets really mad and he destroys the humans because he thinks that they've been misbehaving. So then Tlaloc, who is the god of rain, takes over. And then from him, his sister, Chalchiutlacue, who is the goddess of running water, my favorite goddess from Nahua mythology, she takes over as the sun, but then the other gods taunt her until she cries so much that the earth floods and all of the humans die. So then they have to do it again, a 5th cycle, and it's Nanahuatzin who sacrifices himself to be the 5th sun, and all of the gods are like, we don't want to do this anymore. We need to make sure that Nanahuatzin lasts as the sun. So they all start to sacrifice a bit of their power to keep Nanahuatzin in the sky as the sun. And there's some myth about what happens if the cycle ends and restarts, but yeah, that's, I think, a really good example of a culture that recognized that nature is cyclical, and just because one cycle ends, it doesn't mean that another one isn't going to begin.
Wow, that's amazing. All I could think about, like, I'm listening to this and I'm like, oh, that's another culture that references a great flood destroying the earth.
Oh, the great flood myths are everywhere.
Well, and I'm just like, I knew it. See, I told you, like, all these things are based in some sort of truth somewhere. It's everybody's version of an explanation of something that actually happened.
Oh, girl, we need to talk some folklore sometime because yes, scholars think that there probably was one like really great flood that got incorporated into some foundational myths and then spread around the world.
Yeah, I love it. It's all the truth is in there somewhere.
Yes. Sometimes though, the scholars read too much into the stories that they hear, and they go past the point of truth and they get to absurdity. That's what happened in the 1800s when a folklorist named Max Muller came up with the solar mythology theory. He looked at specifically language, different languages from around the world, and was trying to find their roots. And he came up with the idea that most of language, and honestly, most of culture, can be traced back to a reference to the sun. He went too overboard with it. He started to say that like all of the words we have, even words for like colors, for animals, for like buildings that we live in, he was like, they can all be traced back to the sun because the sun is the most important thing to everyone. And that's just not true. The sun is very important, but to some cultures, especially coastal cultures, they would revere the god of the ocean, perhaps, above the god of the sun. If you live in the desert, maybe the sun sun god is too scary. That's why Inti is not the most powerful figure in Inca mythology. He is the second in command to the god of the sky, who can also control rain. So if you live in the desert, like, rain is going to be as powerful as a sun deity sometimes. So yeah, we don't always get it right.
No.
But it is interesting to think about.
That person was just trying to be like, I did something.
Yeah, put my name on something.
Put my name on something.
If it's good.
Yeah, I came up with something. This is my thing. And the rest of the world was like, we don't want your thing. You can have it. Put his name on it and nobody else's.
Yeah, this is taught as a cautionary tale in folklore programs today.
Oh, wow.
Yeah, that's the kind of folkloric understanding that people had of the sun. And over time, it morphed into a more scientific understanding. But first, we had to figure out what the sun was. And there were a few people throughout history who came up with the idea. There was this ancient Greek scholar named Anaxagoras, who was, as far as we can tell, one of the first people to propose that the sun and stars were all the same thing. He thought that they were really big burning rocks and that the other stars were just too far away from us for us to feel their heat. An Italian astronomer named Giordano Bruno suggested a similar thing in the 1500s, and he was burned at the stake. He was burned alive for heresy against the church. And then other people slowly started to push back against the idea that the sun is special and different from everything else. And so I'd say by the time the 1800s came around, when we had studied our sun and other stars with telescopes, and we were able to measure accurate distances to other stars, and once we developed the ability to study the chemistry of all of these stars, we slowly started to figure out that Anaxagoras was right, and the sun is just another type of star. And then we were able to study it for its scientific characteristics, which I have now. I have all of the numbies for the sun, its specs, if you will. How are you with big numbers? There are going to be some big numbers.
I don't know. Let's throw some big numbers out and see.
Okay. Let's start with distances. The sun is 93 million miles away from Earth, or 150 million kilometers for people on the metric system. And sometimes it's closer to us and sometimes it's further. But the difference between like our closest approach to the sun and our furthest approach is 5 million miles, which is less than 5% difference.
5 million miles.
Yeah. And that's a small distance in space.
Wow.
Earth has a tilt. We're tilted at 23 degrees. So even though the sun isn't really moving, because of Earth's tilt as we go around the sun, it does seem like the sun moves north and south. It moves from about 23 degrees north, which is called the Tropic of Cancer, to 23 degrees south, which is the Tropic of Capricorn. And it was only when I was doing the research for this episode that I realized that those are like the extremes of the ecliptic, that those must be the north and south extremes. And so the tropics, what we call the tropics on Earth, is between 23 degrees north and south, because that's where the sun is focusing its energy. The sun is a G-type star. I was going to ask if you know anything about the types of stars, but you said you came in completely blank slate, right?
Yeah, I don't know anything about any of the stars other than they're just up there burning.
Cool. Yeah, they are up there burning. There are about 7 different types of normal stars, of like stars that are in the main phase of their life. And our sun is smack dab in the middle. We are one of the most average types of stars that you can have. The sun looks yellow from our perspective, but it's actually white. Like when you leave our atmosphere, and if you didn't have our human eyeballs, the sun would look white because it's emitting light at all of the colors. But we do call it a yellow dwarf because it looks yellow to us. The sun is about 4.5 billion years old, and it's middle-aged. So it's going to last about 10 billion years total. That's the average lifespan for a star like our sun. And the cool thing about stars is that if you know how massive they are when they form, you can pretty accurately predict what it's going to do over the course of its life and how long it's going to take to burn through all of its fuel. So for a star the mass of our sun, it takes about 10 billion years to burn through all of the fuel.
Wow.
Does that sound like a long time? I feel like I've been desensitized to these numbers.
Yeah, because you just can't wrap your head around billions of years.
Yeah.
You just can't.
Yeah. I mean, our whole universe has only been around for like 14 billion. So our sun is going to get, to most of that age before it burns through all of its fuel. And then it's going to, stuff is going to happen to the sun after that. It's not like it's going to snap out of existence. It's just taking 10 billion years to burn through the hydrogen in its core. It is mostly made of hydrogen. Like 73% of the sun is hydrogen. Then there's 25% that's helium, and then a 2% chunk that is all of the other heavier elements like carbon, oxygen, nitrogen, maybe a little bit of iron, but probably not much. And those are all a very, very small part that make up the sun. You may have heard that the sun is a burning ball of gas.
Yeah, I've heard that.
That's the common line. But it's so hot and it's so energetic inside the sun that it's actually not gas anymore. It's been heated up to the point where the electrons on individual atoms of these gases get excited and they fly away from the atoms. When you lose or gain an electron on an atom, that is called an ion, and it's now electrically charged. And when you have essentially a soup of those ions that are electrically charged, you end up with a plasma, which is the fourth state of matter. So our sun and other stars are not burning balls of gas, they are boiling balls of plasma, which I think is even scarier.
Yeah, it is. It's funny because as you're describing things, my brain goes so many different places, right? You're like, it's boiling plasma, and I think plasma, and I think Ghostbusters. And I think plasma as in ghosts? What are we talking about here?
Yeah.
And then you're like, no, it's like a normal sun. So I'm like, so we're basic? We're basic out here in the universe with our sun, and there's just so many different questions that go along. That's wild. That's very, very interesting.
Yeah. I do this show, and I like to do it with people who are not experts in space because I have spent so much time sitting with this information that I don't remember what it's like to learn it for the first time anymore. And so it's really cool to see you, making these connections to Ghostbusters and ghost plasma, and to things that you've heard about, what's going to happen to the Earth one day. It's really nice to see you making those connections.
Oh yeah, I'm happy you say that because I've had a lot of teachers in my life that did not think it was nice. I've been in a lot of classrooms where they were just kind of like, Tiffanee, calm down. That imagination of yours, we're going to need you to channel that, funnel that.
No, that's so sad. And I had a bunch of those teachers too. That's why I didn't find astronomy until college. But yeah, there's no shame in not knowing anything. We all have to learn things for the first time eventually.
Yeah, it's no shame in being so the sun might be just a bunch of ghosts burning up in the sky. Maybe, whatever.
Yeah, maybe. Science cannot say no right now. Exactly. I have not learned anything in my classes that tells me the sun isn't made definitively of a bunch of ghosts.
Just burning up there having a party. We don't know.
We don't know. Hey friends, Tiffanee went to go get us some apple cider in both liquid and solid state, in the form of apple cider donuts. So I figured I'd share some messages with you and also thank all of the patrons who support this show every single month financially. I couldn't make this show without you. I want to give a huge shout out to the sun-like stars who support us with their golden light and their perfect gravitational fields, Scott Reynolds, Augustine, and Tom T. If you want to join this amazing group and support this show and get research notes for almost every single episode, you can join the Patreon for just about $1 per episode. You can also sign up for a whole year up front and end up getting a 13% discount. That's 1 percentage point for every constellation in the sun's path across the sky. You can find that Patreon info and merch and more at palebluepod.com, or if you already know you want to support us financially, head right on over to patreon.com/palebluepod. It would be greatly appreciated. Okay, I have a podcast recommendation for you. This is another show in the Multitude Network, and it's called Join the Party. This is an actual play podcast with tangible worlds, genre-pushing storytelling, and collaborators who make each other and the listeners laugh each week. The DM is Eric, and he's joined by emphatic players Amanda, Brandon, and Julia, and together they welcome everyone to the table, from longtime TTRPG players to folks who have never touched a role-playing game in their lives. You can hop into their current campaign, which is a pirate story set in a world of plant and bug folk, which they built themselves. It was a home-brewed world. Or you could marathon their completed stories with the Campaign, a Monster of the Week game set in a weird summer camp. Their second campaign was a modern superhero game, and their very first campaign was for fans of a high fantasy story. So there are so many options for you to choose from. Once a month, they release the After Party, where they answer your questions about the show and how they play the game, and that's how they can say that they want everyone to join the party. So what are you waiting for? Search for Join the Party in your favorite podcast app or go to jointhepartypod.com. Now I have a message from Brian and Robin.
Hello, I'm Brian Cox.
And I'm Robin Ince. He understands the nature of the universe.
And so does Robin.
Well, do you know what? I do have my moments, especially after this new series, The Infinite Monkey Cage, because we are joined by experts at Bletchley Park who are talking about cyber warfare, an unexpected history of the body at the Royal Society. Plus, we'll be talking about de-extinction, elasticity, and embryology.
And there will be comedic interludes and Pam Ayres on hedgehogs. I mean, she's not riding the...
Listen wherever you get your podcasts.
Okay, Tiffanee is back. Her hands are full, so let me go help her, and then we will get back to this conversation about the sun. So it's the sun is middle-aged, and it's much bigger than the Earth. How many Earths do you think could fit inside the sun?
Let's take a wild guess here.
Yeah.
I'm going to say like 10,000.
Okay. I could see the gears turning. You're like, do I want to go really over? Do I want to go kind of under?
The price is right over here.
Right. You can't go over or you lose.
Right.
It's about 1 million Earths. 1.3 million Earths fit inside the sun. That's how big it is. And its mass is 333,000 times the Earth's mass. So a third of a billion times more massive than the Earth. The sun also rotates. It's not just sitting there. It is rotating on its own axis. And a day on the sun is about, it actually, because the sun isn't solid, because it's a plasma soup, different parts of the sun rotate at different speeds. So at the equator, it takes about 25 days for the sun to rotate. But when you get closer to the poles, it gets a lot slower, and it takes about 36 days for that part of the sun to make one full rotation, which is weird. It's weird for me to think about. But yeah, the sun is rotating, and we know it is because we can see the sunspots. So we see them moving across the face of the sun, and the sunspots themselves aren't moving. They are stuck in place on the surface of the sun. They move a little bit, but not as fast as the sun itself rotates.
Oh, that is interesting. At first, I was a little lost, like how could things rotate at different times? But then I had to remember that if it's like a swirly, like mixing cake batter kind of thing.
Yes, exactly. The Earth is a solid rock, so we're all moving together. But the sun is not solid. Parts can move around from one part of it to another, and they have less loyalty to each other than the parts of the Earth do.
Yeah. I'm wondering if the sun will ever at some point in time be like, okay, we're whirling and moving in this swirl, but like, can it change shape? You know what I mean? Like, because there's nothing, like what's holding it together?
Gravity. Gravity holds it together and does a pretty good job of forcing it into a spherical shape because gravity works the same in all directions. So it pulls everything towards the center. But there are little flares and things that can morph, at least at the surface, a little bit the shape of the sun. But that's like adding a mountain to the surface of Earth. Like, it doesn't change the overall shape that much, but locally you can see there's a difference.
Ah, okay. Interesting.
Would you like to talk about the parts of the sun, like its anatomy, its its body parts? Because it's layered. You know, the sun is like an onion, It's like an ogre, and it has at its center a core. This is where the fusion happens, so it's the hottest part of the sun. Temperatures in the core can reach around 27 million degrees Fahrenheit. That's because it's where the fusion is happening. So a lot of energy gets produced and gets converted into heat, but some of that energy is also in the form of photons. Photons are particles of light. So they get formed in the center through fusion, and then they work their way out from the core of the sun to the surface to then travel through space to get to us. And those photons, they travel at the speed of light. So it takes them 8 minutes to get from the surface of the sun to the Earth. That's just because of how far away we are. But it takes the photons, it can take them anywhere from like 10,000 years to 1,000,000 years to get from the core of the sun to the surface.
Of just the sun, not even to the surface of the Earth.
Of just the sun. It takes them a really long time to get from the core of the sun to the surface, because as the photons are moving, they keep hitting other particles, and then they get like ricocheted in another direction. So they're not taking a straight path. We call it a random walk. It's like a little pinball, just getting bounced around for 1,000,000 years until it eventually randomly reaches the surface of the sun, and then it can travel in straight lines because it's not bumping anything in space. Yeah, it takes them a long time.
Wow. That's crazy. That's wild.
That's one of my favorite facts about the sun is that these photons that reach us are so old. You know, they could have been formed 1,000,000 years ago in the core of the sun.
Oh, so they take forever. They get out. They finally get out.
Mm-hmm.
Takes them 8 minutes to make a beeline to Earth.
Yes.
And then they get to Earth. And then what do?
Well, and then they probably hit something, like they would come in contact with a tree or the ground or your body or something. And when a photon hits a particle, when it hits an atom, it gets absorbed by that atom. And then the atom gets excited. Like however much energy was in that photon, the atom then absorbs and it rearranges its electrons to like be in a more energetically excited state. So that's what happens. That's probably like we feel warmth when photons hit us, and our particles get a little bit more excited.
Oh my gosh. So the sun is like literally impregnating me with its photons all day, every day.
That's one way to put it, yes.
Photon sperm just like flying through trying to get to me.
I'm crying. Yep. They do cut in illustrations when we draw the path of photons in science. It does kind of look like sperm traveling to the egg. So I can't say you're wrong.
That's what it sounds like. And I'm just out on the beach in a two-piece, like, yes, let's go.
Yep. I'm never going to be able to sit on a beach with peace again.
I love that. The next time my mom asks me, like, where her grandkids at, I'm going to be like, you're not going to believe this, but we have I am birthing celestial beings, okay? I got photons inside of me. I love it. When I get the photon and I get all excited and it gets excited and then it emits like energy.
The excited state doesn't last a very long time because it's hard for a particle to maintain that amount of energy. So it does go back to its ground state fairly quickly.
Okay. So happy about it though.
I'm happy about this. This comparison you've drawn.
Yeah, girl, my imagination does not stop.
It doesn't. No, I am seeing a little piece of the scene inside your brain right now. So the core, it makes all those photons that then, when they make it out to the surface 1,000,000 years later, can then go on to impregnate all of us here on the surface. And then as you move out towards the surface of the sun, you have different layers. The first layer outside the core is called the radiative zone, where the photons are able to travel and like the heat and energy are able to travel through radiation. Maybe you remember this from like some high school science classes, but there are 3 different ways that heat and energy can get transported. Radiation is a really effective way, but you need some sort of medium for it to move through. And then there's convection, which is what happens with liquids and fluid things. It's like the particles of liquid or like the little molecules of liquid interact with each other and transfer heat that way. So there's that zone where radiation is what dominates the heat transfer. But then you get to a zone where it flips. Like the interface between this is called the tachocline. It's the interface layer between the radiation zone and the convection zone. And in the convection zone, the mode of heat transport flips to convection. And that's because this part of the sun, it has a really steep density and temperature gradient. The way that the density and temperature change as you move through this layer, it changes really quickly. So at the bottom of the layer, it's much hotter because you're closer to the core of the sun, so the material is less dense. And as you get to the top of the layer, you're further away from the sun, so it's cooler, and the material is more dense. Maybe you've noticed, if you've gone swimming or if you've cooked before, I'm sure you've cooked before, that lighter materials that are less dense, they float on top of things that are more dense. And so in the convection layer, material at the bottom is much less dense than the material right next to it because the density changes so fast. So the way that material gets transported through this layer is through the less dense material at the bottom just floating up to the top. And it's kind of like boiling. This is the boiling layer of plasma that I talked about earlier. And then between those two layers, there's the tachocline, which is where a lot of the magnetic activity from the sun is generated. And then you get to the photosphere of the sun, where the temperature is around 10,000 degrees Fahrenheit. And then the chromosphere is where things get weird. And instead of getting cooler as you move away from the core to the surface, in the chromosphere, it flips so that it starts getting hotter as you move away from the core. So the chromosphere's average temperature, or by the time you get to the top, its temperature is 14,000 degrees. And that is because the top of the chromosphere is next to the corona of the sun, which is one of the areas of pure mystery remaining in solar science, because the corona is the outer atmosphere of the sun. We actually can't see it unless there's an eclipse or unless there's some sort of instrument blocking the light of the sun. But the temperatures in the corona are around 1,000,000 degrees Fahrenheit. And we don't know why. We don't know why the outside of the sun is hotter than the inside of the sun. And we're trying to figure it out now.
Okay, that is interesting. My little peanut brain would have no idea why.
Yeah, we are actively trying to figure that out because we haven't learned everything in space yet.
Yeah, maybe it's a protective layer.
Maybe that could work.
Yeah, I don't know. I'm just making some stuff up.
Maybe it's because all of the photons, they're done with their random walks through the sun and they get to the surface and they can finally breathe. Maybe the heat of the corona is from all of the photons being exhausted from their trip.
Yeah. That could be a thing too. They're just out there oh, we need to breathe.
Do you know how powerful the sun is? It gives us so much energy. What's the most energetic thing you can think of?
A toddler.
Yeah, okay, fair. I wonder what the average power output of a toddler is, but we have measured the average output of the sun. It is 4 times 10 to the 26th power watts. So think of your 40-watt light bulb or 60-watt light bulb. This is many, many thousands of trillions times more powerful than your average light bulb. A watt is a unit of power, so it's energy per time. And the sun, in 1 second, is as powerful as 1 trillion atomic bombs exploding.
Oh my gosh.
And the sun's going to be around for 10 billion years. So
wow.
It's quite powerful.
Yeah.
That's why people talk about solar energy as much as they do, because they're like, the sun is putting out these massive amounts of energy, just letting photons escape out into space. And if we could somehow harness them, then we could power everything we would want to here on Earth right now.
Yeah. I'm like, why aren't we doing that? Everything should be solar powered. We should be storing that up in places. Yeah.
Right. I'm sure that the engineers have their reasons. I'm sure it's more complicated, but from the astronomy side, we're like, hey, look, the sun is there. Let's use it.
Great.
So it's giving us a lot of heat. It's giving us a lot of brightness. It's also generating a lot of magnetic energy, a lot of magnetic activity. All of the flowing plasma, which is a soup of charged particles, when they pass by each other, they generate magnetic fields. And recent studies have pointed to that interface layer between the radiation and convection zone, the tachocline. People have pointed at that as the special place where a lot of this magnetic energy is produced because of the way that those two layers interact with each other. It's so much more powerful than Earth's magnetic field always, but it varies a lot because the sun has this magnetic cycle that it goes through where it gets weaker and stronger over time. But for some comparison, the Earth's magnetic field has a strength of 0.5 Gauss. Gauss is like a unit of magnetic activity. The sun at its weakest has a magnetic field of like 1 Gauss, so twice as strong already. And at its strongest, when it's at, the peak of its magnetic activity, like it is right now, it can get up to 3,000 Gauss. So, 6,000 times stronger than the Earth's magnetic field.
That's a lot. But what does the magnetic field do though?
Yeah, great question. So here on Earth, our magnetic field protects us from the charged particles that are coming off of the sun. It helps us navigate. Animals navigate by it. In the sun, it can produce things called sunspots. Those are the dark spots that you see on the surface of the sun. And that's happening because there's heightened magnetic activity there, which is changing the temperature. It's contracting things in or expanding things out. I think that this is also another open area of research where we're still trying to figure out exactly how sunspots work, but we do know that they are places where there's strong magnetic activity that for some reason make that part of the sun's surface cooler than the rest of it. They produce flares. The magnetic field of the sun produces these magnetic flares, which sometimes produce something called a coronal mass ejection, where the flare is so strong that it actually flings some of the sun's plasma out into space, and that can come towards us here on Earth. And then the potentially scary thing is when the sun's magnetic field interacts with our own. It can cause some interruptions to our own magnetosphere, which is how we get aurora. So you get pretty lights. But it can also interrupt with our satellites. It can mess with our GPS. It can mess with our communication systems, and it can mess with our power grid, which works by having electrons move in a line. And when there's a strong magnetic field, it can jostle around those electrons. So the magnetic field can do a lot. And right now, the sun is at its maximum magnetic activity because it has this 11-year cycle. So we are experiencing a lot of solar flares, a lot of geomagnetic storms. Twice this year, people at southern latitudes, around even as low as Florida, I saw, people were seeing the northern lights just because there's that much magnetic activity.
And this is why my mom's cell phone keeps going out. So I told her, she's like, I don't know what's wrong with my cell phone. I'm having a problem with my service. And I'm about to call her right now and be like, I know exactly what is wrong with your cell phone service. Mm-hmm. This is also why I'm like, everybody should learn how to read a map, because we have GPS and nobody knows how to read a map anymore. Mm-hmm. And I'm like, but wait, this is where my little bit of conspiracy theory comes in. I'm like, oh my God, what if all of the electronics just stopped and nobody would know how to get anywhere? Mm-hmm. See?
More fuel to your conspiracy theories is that other countries in the world have land-based navigation systems that would not be taken out by a geomagnetic storm. But the U.S., underdeveloped or cut funding from from our system to do that. So yeah, we are now reliant upon satellite-based navigation systems here in the U.S. And if a really strong flare comes through, oops.
See, I know I wasn't crazy. No.
Not for this anyway.
I might be a little bit crazy, but not about that. No.
Look, we all have our crazy corners that we go to. I want to give us some scope, some perspective zoomed out so that we know where the sun and our solar system sits in a wider context. We are about 25,000 light years from the center of the galaxy, and the galaxy is about 100,000 light years across. So we are kind of smack dab in the middle of the Milky Way's disk, halfway between the center and the edge of the galaxy. And we are right in between some of the spiral arms, which is really good. We are right next to an offshoot of the Sagittarius arm called the Orion Spur. And so as the spiral arms move, we also move with them around the Milky Way. It takes us 240 million years to make one trip around the Milky Way galaxy. So the sun is about 18 sun years old. It's made 18 trips around the galaxy, and it travels at 250 kilometers per hour.
Okay. Yeah. So the Autobahn of the sky. Okay, cool.
Mm-hmm. And we know that in the future, to answer your question from early in the episode, we know based on the sun's mass that in about 5 billion years, it's going to run out of hydrogen in its core. And hydrogen fusion is what keeps the sun in its current state, because gravity is trying to pull itself in and the energy from fusion is pushing out. So when it runs out of that fuel, it's going to kind of collapse in on itself. But then when it gets smaller, it will get denser and it will heat up. So another round of fusion will get triggered, and it will do this a few times until it really runs out of fuel. And all of that extra heat that it's been producing as it contracts will make the outer parts of the sun, the outer atmosphere, puff up really, really far into what we call a red giant. And we know that the red giant phase is going to overcome Mercury and Venus, like that's how big it will get. And Earth is on the cusp. We're trying right now to figure out if the sun will engulf the Earth or not, but it probably will. Mars is probably safe. And then the other outer gas planets, they're going to be safe too. And then after the red giant phase, all of that outer material is just going to kind of like shed away and be carried away by the winds of the sun. And what's left behind will be a little white dwarf, just a tiny little hot chunk of rock that is slowly radiating away all of its heat. It's kind of like the core of the sun left over. And it's going to stay that way for many, many millions of years.
Okay. So what I heard is that the sun is going to like reinvent itself a couple of times. Like, it's going to be like, no, I'm going to show up. No, I'm back and better. And then, no, I'm going to show up again. And then it's like, no, I got a new hairdo. I'm back. And it's going to do that a couple of times. And then eventually it's going to be
always with like a new hairdo. It's going to be a new style choice every time. Mm-hmm.
Right. And then it'll eventually be like, I'm a star now. I'm retired. Like it retires. And when it retires, it becomes a star.
It becomes a star remnant at that point. Like an emeritus star, an alumni, if you will.
Okay. Oh, because it's kind of like a star now.
Yeah, so it's a star now. While it's still actively fusing the hydrogen in its core, astronomers say that it's on the main sequence. Like we've graphed all of the types of stars that there are, and there is this kind of main corridor, this main group that most of them fall into when they are actively fusing. And when they stop fusing, they move off the main sequence, and there are a bunch of different paths they can take based on how much they weigh.
Okay. And are there other like retired stars out in the sky?
Yeah, black holes are retired supermassive stars. Neutron stars are also retired stars. Pulsars, magnetars, those are all types of retired stars.
Okay. I'm so happy that I'm not going to be alive during this process.
Same. Although I think it would be really beautiful. Actually, I think that the sun would become so big and like dim in the sky that I think you would be able to look at it more easily. And it would just take up so much of the sky and just be like a presence.
So everything happens in these crazy time frames, like, right? So like our concept of time versus the universe's concept of time. So when the star kind of collapses on itself before it like rebirths itself. In our time, is that like 10 years? Is that like 5 years? Is that 24 hours? Like,
The whole process with all of the accordioning and the red giant phase itself should probably take at least 1 billion years, but we're still trying to really narrow down that value to be more precise. And the way that we study this part of the sun's evolutionary phases is by looking for other red giant stars out in the universe and like trying to study enough of those that we can kind of understand based on statistics how our sun should behave.
okay. So yeah. Well, the reason I was asking is I was just wondering if anybody during their lifetime would be able to witness any part of this process from beginning to end, but it doesn't sound like it, because we might not even notice that this is the phase that we're in, because our lifetime just doesn't allow for us to see anything happen from beginning to end.
Right. Yeah. The most that a human lifespan would overlap with is like you might be able to see the sun's temperature and brightness change by like a few percentage points. But I don't think it would be a visibly noticeable difference in the sky in one human's lifetime. But that's why oral storytelling and, like the preservation of knowledge is so important, because from one generation to the next, they would be able to see that trend if they were keeping track of it.
It's so interesting. I think that people were probably trying to with all these like sundials on Earth and people saying that they, but they can't figure it out because the language is so old and the stories, because of war or whatever, they weren't passed down or something was looted. And so it's unfortunate that we aren't able to interpret the messages that people were trying to leave us. It's so sad.
Mm-hmm.
We'll see how long the internet can hold up. And
we're already getting rid of like the Wayback Machine. A lot of archives are already being taken down. I don't know.
Right now,
maybe this is my conspiracy theory, but it doesn't look good.
Any information that I had on a floppy disk is gone. I will never know what that information is. If it's burned onto a CD, it's gone too. So we're saving stuff on Google Drive right now. I don't know what's going to happen in like 75 years. That might be gone too. I don't know.
Yeah, that's a really scary thing to think about. I think that's scarier than a black hole. The mass loss of information for me is scarier than a black hole.
Yeah.
But at least for now, we have a pretty good database of information on the sun because we are actively studying it all the time. I wasn't much into heliophysics, which is what the field is like formally called, but I did go to the Harvard-Smithsonian Astrophysics Research Lab's solar physics room once, and it's a room. All of the walls are screens, and each screen has a different type of picture of the sun on it, like in different wavelengths of light or with different filters on it. And it was so cool to see, because in most of astronomy, you're really far away from the thing you're studying, and you don't actually get that much information from it. But heliophysics has a surplus of information. There are currently 19, just NASA alone, active missions studying the sun, and 13 more NASA missions are planned, and other countries around the world. I know India has been working on a solar probe. China, Russia, they have their own solar probes. But we sent the first probe out into space to study the sun in the 1950s. It was called Explorer 10, and it just orbited the Earth and looked at the sun. And then it took us until 2021 to build a spacecraft that actually went to the sun and like touched it. So in 2018, we launched the Parker Solar Probe. That was the first mission to fly through the atmosphere of the sun. It flew through the corona. So a lot of developing that was like putting together this special casing that could protect it from, because we talked about the 1,000,000-degree environment that is the corona. So it flew through it. It got there in 2021, and its goals are threefold. They want to trace the flow of energy in the sun system. They want to figure out why the corona is so damn hot. And they want to figure out what powers the solar wind, and like how exactly does that work? Because there is this wall of electrically charged particles coming off of the sun all the time, like a wind moving through our solar system. And these are all unanswered questions that hopefully the Parker Solar Probe and, the dozen other missions that people are working on can answer.
I want to know what kind of metal can just go up and touch the corona of the sun, unless it's like vibranium. I'm like, is vibranium a real thing? Like, what could possibly get that hot and not melt?
Yeah, this is why materials science and astronomy has such a tight relationship. I think that so there are like the metal instruments, and then there's this casing, this thick casing of, it's not cement, but it's something like cement to try and insulate it from the heat of the sun.
I mean, that by itself is like, wow.
Yeah.
And why aren't we making pots and pans out of this? Like, wow. For real, like, we should be building buildings out of this, or things can't catch on fire. And like, I mean, it's probably very expensive, but is it something that's just like hanging out in the Grand Canyon?
It's very expensive.
Yeah, it has to be.
Like these materials are things that have to be produced in a lab.
Okay, so this is not something like coming directly from the earth. Huh? Okay.
No. I think like the ingredients probably come from the earth, some of them, but then they have to be mixed and magicked and spell casted to be effective.
Yeah, that's crazy though. That's crazy that they found something to go into the corona of the sun. That's wild. The universe is crazy. So much weirdness happening.
I know, and I love it.
Yeah.
But that's why I'm a friend to the universe, because I'm a little weirdo, and I love hearing about all of this stuff.
I love that, though. I love that in you. Like, the weirdo in me recognizes the weirdo in you.
Yes. Weird game, recognize weird game.
Word.
That's all I had prepared about the sun. How are you feeling about it now that you've learned all of its specs and history?
I mean, it's fascinating. It really is. I'm so happy that you had me come on, because I love stuff like this. It just puts a lot of things into perspective. You think about yourself, like I think about my day, and I'm like, I've got to do this and I've got to do that, and what's happening in my world. And then we talk about this, and I'm like, no, there's nothing happening in my world. What's happening in the universe? Like, I should be able to manage what's happening in my world compared to, the sun.
It does really help me a lot to think about things from a more astronomical perspective when I get really stressed out about my small human problems. Like, that deadline doesn't matter.
Right.
It truly doesn't matter that I missed that train. Like, it's all nothing compared to the universe.
Right. And the millions of years and the things that are happening. And I do also really like that we kind of touched base on, we are part of the process. Like, the idea of these little photons impregnating me is going to stay with me for forever. I am literally part of the sun's existence, like the process.
And honestly, photons from other stars too. They're coming at you, and they hit your body before they hit the ground, some of them. So I was in Chile a few years ago, and it was dark enough that I saw my shadow cast by the Milky Way. And the knowledge that those photons had traveled, 100,000 light years to be stopped 3 feet short of the ground by like my chest, it was, I didn't feel pregnant, but I did feel very connected to the universe.
Yeah, that's so great though. It's kind of like, I made a difference. I'm in the mix.
We are all space.
Yeah, we're all part of this space and time. Yeah.
Before we wrap up, before we do our leaf peeping, could you brag about yourself for a second and tell the audience where they can learn about you and your work online?
So as we discussed, I am a comedian. I can be found on Instagram. That's the easiest way to find me. Tiffanee with 2 E's. So TIFFANEE_giggles. That's my handle. And I also have a website, Tiffanee_giggles_Lee. If you Google Tiffanee Lee and you spell it correctly, I'll pop up.
Those links are also in the show notes. So
yeah, and I produce 2 different shows too. So we have one show I co-produce. It's called the Time and Again comedy show, and we feature all BIPOC comedians. So BIPOC, Black, Indigenous, people of color. So we always have a lot of diversity in that show. And then the other show that I produce by myself is called the Tegareg comedy show. And my family is Jamaican. So Tegareg is a Jamaican word and means uncouth. So
I'm going to go to that one.
yeah, we have a really good time. We get a lot of people that are headlining, and honestly, those tickets are probably worth at least $60. But it's a lot less. It's usually like $7 because I ask people to come in. Yeah, they work on new material. It's really great. So both of those shows are the third Sundays of every month, but you could find all of that stuff online.
Do that. Go to the links in the episode's description and you'll be able to keep up to date on Tiffanee's work. I will be at one of those shows at least in the future.
Yes, please come through. I feel like now I have to make a set about the sun. Like
this is my secret plot. This is my great scheme that I'm going to teach all of the comedians about science and then they incorporate it into their sets. And then it just spreads from there.
Absolutely. I'm such a big nerd. I actually, like in the best way possible though.
Yeah.
Yeah, I actually started doing some research the other day because I was sitting at home one day and I thought to myself, volcanoes are kind of like the Earth's pimples.
Yes. Yes. Some of them are like really short and mostly underground. There's a really painful one. Some of them are really tall and they erupt so easily.
Exactly. So my brain is already living in that world.
Clearly. Oh, I love it. This has been such a delight. Thank you for letting me yap at you about the sun. I'm glad that I got to talk about the mythology of it too. That made my heart warm. And listeners, go check out Tiffanee's comedy shows. Maybe you'll see me at one of them. And we're going to go do some leaf peeping. But no matter what the foliage around you looks like, you're still space. Pale Blue Pod is hosted by me, Dr. Moiya McTier, aka the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.